Okay, we're doing problem 3.91, and it says, the hydrometer shown sinks 4.7 centimeters in water with a temperature of 15 degrees Celsius. The bulb displaces 1 cubic centimeter, and the stem area is 0.1 square centimeters. Find the weight of the hydrometer. So we're going to use Newton's second law. Newton's second law states that the sum of the forces equals mass times acceleration. So what are the forces in this problem? Well, we have the weight of the hydrometer, which is what we're trying to find. So let's denote that as downwards W. And what's keeping the hydrometer up? Well, that's the buoyant force. So I'll label that as B. So those are simply all our forces in the system. So I'm going to note going up as positive and going down as negative. So I'm going to write sum of the forces equals MA, which equals B minus W. And these are solely the forces in the y direction. Since we're only looking for weight, we really only need to look in the y direction. So we really don't care what's in the x direction or z direction. We're just focusing on y. So how else can we simplify this equation? Well, it doesn't say that the velocity is changing anywhere. So we can assume that the acceleration equals 0. Which states that this whole thing, this equals 0. We can then simplify that to B, the buoyant force, equals the weight of the hydrometer. So how can we solve for B, the buoyant force? Well, you've probably learned in your class that B equals gamma, which is the specific weight of the fluid. In this case, it's going to be water, so H2O, times the volume displaced. You might have also learned that B equals rho G times the volume displaced. Rho times the acceleration due to gravity just equals specific weight. So since the first formula I wrote just involves one term, I'm going to use that instead. However, feel free to solve it the other way too. It should give you the same answer. Okay, so how do we find these two values? Well, specific weight of H2O is pretty easy to find. We're just going to look at the problem statement and find out the information that they truly give us. So it says that it gives us water and 15 degrees Celsius. So in your textbook that you probably have, and probably does have a chart of properties of fluids, such as water. So here it gives us, let's first look at the temperature, 15 degrees Celsius. And we need water, which this whole chart is of. And tells us the specific weight of water at 15 degrees Celsius is 9,800 newtons over cubic meters. So let's write that down. So B equals 9,800 newtons over cubic meters. And again, we just found that from the chart. And make sure to take note that it gave us newtons over cubic meters. So that tells us that our volume displaced must also be in cubic meters. So let's find the volume displaced. So what is the volume displaced? Well, it's all of this. Everything that's displaced under water, we should take into consideration. Make sure to not account for this. That's above the water, so it's not displaced. Okay. So let's look at what it gives us. It tells us here that the volume here of just the bulb equals 1 cubic centimeter. But again, as I said before, we need to make sure we take the volume in cubic meters. So what is that in cubic meters? Well, that's simply 1 times 10 to the negative 6 cubic meters. Okay, so what about the volume displaced of the neck of the hydrometer, like right here? How do we find that? Well, it says in the problem statement that Z equals 4.7 centimeters. However, that's not in units of volume. Volume's always a unit cubed. So here we have just centimeters. So we need to multiply this Z by an area unit. And here we have A equals 0.1 centimeters squared. However, both of these units are in centimeters. This one's centimeters squared, and this one's just centimeters. So if we convert both of these to, we'll convert meters. If we convert Z to meters instead of centimeters, and A to meters squared, and multiply A times Z, the C, we'll get our volume of the neck. So let's do that. So let's first convert Z from centimeters to meters. So that just equals 0.047 meters. And what about A? Well, when you convert that to meters squared, so what is that? That's 1 times 10 to the negative 5. And we're going to convert A times Z to get a final unit of volume, which is cubic meters. So that's simply our total volume displaced. Okay, so B equals 9,800 newtons over cubic meters times volume displaced. Let's first do the volume of the bulb. So that's 1 times 10 to the negative 6 meters cubed plus, this is the bulb right here that I just wrote, plus A times Z. And again, that's the volume of the neck of the hydrometer. 1 times 10 to the negative 5 meters squared times 0.047 meters. And again, meters squared times meters will give us cubic meters, which is what we want. So this is our final formula, and we just need to solve for it. So that should give us B equals 0.014406 newtons. And why newtons? Well, because newtons was given in our gamma H2O value right here. So we know that the units of our force will be newtons also. So as a summary, our gamma H2O is 9,800. This, which we just got from the chart, and our volume displaced was the volume of the bulb right here times the volume of the neck, which is this blue part right there. Well, this A times Z. And we simply we just solve this problem and we get buoyant force equals 0.014406 newtons. And again, we're solving for the weight, so make sure that's actually W equals 0.014406 newtons. And again, since the first formula we wrote in this problem, we found out that B equals W. So we essentially found W through B.